How are large structures designed to maintain equilibrium? Imagine a giant skyscraper standing tall against the wind or a bridge holding steady over a busy river. How do engineers make sure these huge structures stay balanced and don't topple over? That's where the science of equilibrium comes into play. When designing large structures, engineers focus on making sure all forces and moments acting on the structure are perfectly balanced so it remains stable and safe. This is a core idea in the principles of mechanics and structural engineering. First, engineers analyze all the loads the structure will face. These include dead loads, which are the permanent weights like walls, floors, and roofs. Then there are live loads, which are temporary or movable weights such as people, furniture, or vehicles. Environmental loads are also considered, including forces from wind, snow, earthquakes, and temperature changes. Knowing these loads helps engineers understand what the structure must withstand. Next, they determine the load paths. This means figuring out how forces travel through the building or bridge, from where the loads are applied, through beams, columns, and other parts, down to the foundation and into the ground. The goal is to make sure these paths are continuous and strong enough to carry all forces safely without causing failure or excessive movement. To analyze these forces, engineers use the principles of statics and dynamics. Statics helps them understand forces in a state of rest or constant motion, where everything is balanced. Dynamics looks at forces that cause motion or vibrations. For equilibrium, the focus is on static conditions where the structure stays still and stable. For a structure to be in equilibrium, three main conditions must be met. The sum of all horizontal forces must equal 0. The sum of all vertical forces must also equal 0. And the sum of moments, or torques, around any point must be 0 too. These conditions ensure the structure does not rotate or slide. Material choice is also vital. Concrete, for example, is very strong in compression but weak in tension, so it's often reinforced with steel bars. Steel can handle both tension and compression and is more flexible, making it ideal for many parts of large structures. Wood is lightweight but sensitive to moisture and has different strength properties. Engineers select materials based on how they respond to forces to prevent deformation or failure. Redundancy is another key idea. It means adding extra elements or alternative load paths so that if one part fails, the whole structure still remains stable. This safety margin helps prevent catastrophic collapse. Modern tools like computer simulations and structural analysis software are used to test how structures behave under various loads. These tools apply mathematical models and finite element analysis to check for equilibrium and identify weak points before construction begins. Engineers also consider serviceability, which means making sure the structure does not deflect, vibrate, or crack excessively during normal use. This keeps the structure safe and comfortable for its occupants. In complex structures, additional techniques may be used to maintain balance even when conditions change. For example, special systems of springs or linkages can help offset gravitational forces and keep the structure stable regardless of orientation. In summary, designing large structures to stay in equilibrium involves analyzing all the forces involved, creating continuous load paths, choosing the right materials, ensuring forces and moments balance out, adding safety features, and using advanced computer tools. This careful process helps ensure that these massive constructions remain safe, stable, and functional for many years to come.